The Telangana earthquake, a wake-up call. On December 4, 2024, the ground shook in Telangana, sending waves of panic and confusion through the region. A magnitude 5.3 earthquake had struck, a force strong enough to be felt far and wide. Its epicenter was near Mulugu, a small town that suddenly found itself at the center of a natural disaster. This was the strongest earthquake in the region in over 50 years, a stark reminder of the area's vulnerability. People felt tremors across Telangana, Andhra Pradesh and Maharashtra, with many rushing out of their homes in fear. The earthquake affected a large area with a radius of 250 kilometers, impacting numerous communities. Thankfully, there was no major damage. However, some houses collapsed and several walls were damaged, leaving many in distress. The earthquake happened at a depth of 40 kilometers deep within the Earth's crust, making it a significant geological event. It lasted for 10 seconds, but those 10 seconds felt like an eternity for those who experienced it. Videos of the tremors spread quickly online, capturing the attention of people worldwide and sparking conversations about preparedness. This event was a reminder of the power of nature, showing us how small we are in the face of such forces. This earthquake was a wake-up call, urging communities to come together and discuss future safety measures. It showed us that even areas not known for earthquakes can be at risk, highlighting the unpredictability of such events. It highlighted the need to understand these events better, pushing scientists to study and analyze the data more closely. We also need to find ways to stay safe through preparedness drills and having emergency kits ready, ensuring we are better equipped for the future. Shifting Earth. Why do earthquakes happen? Earthquakes happen because of movements deep inside the Earth. These movements are caused by the intense heat from the Earth's core, which creates convection currents in the mantle. The Earth's outer layer, known as the crust, is made up of large pieces called tectonic plates. These plates are always moving, although very slowly, at a rate of a few centimeters per year. Sometimes these plates push against each other. This creates pressure that builds up over time. When the pressure becomes too much, the plates can slip suddenly, releasing a huge amount of energy. This sudden release of energy causes the ground to shake violently. This shaking of the ground is what we call an earthquake. The area where the plates slip is called a fault line. Fault lines are fractures in the Earth's crust. The Telangana earthquake happened along the Godavari Fault, which is a significant fault line. This is a major fault line in India, known for its seismic activity. It runs through the states of Telangana and Andhra Pradesh, affecting both regions. The movement along this fault caused the earthquake on December 4th, highlighting the dynamic nature of our planet. The dam problem, when water shakes the ground. Earthquakes can happen naturally, but human activities can also trigger them. One such activity is the building of large dams. Dams hold back huge amounts of water. This water puts a lot of pressure on the ground. This pressure can affect fault lines. It can make them more likely to slip. This can trigger earthquakes. This is called human-induced seismicity. The Godavari River, near the earthquake's epicenter, has many large dams. These dams are important for irrigation and providing water, but they might also be increasing the risk of earthquakes. This is a serious concern. We need to find ways to manage this risk. A solution for a safer future, embracing smaller dams. There is a way to reduce the risk of dam-induced earthquakes, which have been a growing concern in many regions. We can build smaller dams instead of large ones, which are often more susceptible to causing seismic disturbances. Smaller dams hold less water, making them inherently safer. This means they put less pressure on the ground, reducing the likelihood of triggering earthquakes. Multiple smaller dams can be built to store the same amount of water as a large dam, but with distributed impact. This distributes the weight of the water more evenly across the landscape. It reduces the stress on any one point, making the entire system more stable. This can significantly lower the risk of earthquakes, providing a safer environment for nearby communities. Smaller dams also have other benefits, such as supporting local ecosystems. They can improve water distribution, ensuring that agricultural areas receive adequate irrigation. They can also be better for the environment, creating habitats for wildlife and preserving natural landscapes. Switching to smaller dams is a big task, requiring careful planning and coordination, but it is an important step towards a safer future, ensuring both human safety and environmental sustainability.